The Lord be with you and good day, everyone. I am Jericho B. Amon from BSA 401. So for today's video, I'm going to discuss to you the break-even point in linear programming or the maximization of profit from our lessons in management science. So without further ado, let's get started. First, we're going to tackle the break-even point. So the break-even point in economics and business, and specifically in cost accounting, it is the point at which the total cost is equal to the total revenue. So there would be no net loss, there would also be no net gain. So basically, it is the point or it is the total units of products that are needed to be produced or sold for a company to break even. So to break even means that the cost equates the revenue. So there would be zero profit and there would also be zero loss. So what is the importance of actually getting the break-even point? So company or firms or whoever it is get the break-even point for them to be able to get the optimal number of products that they must produce and sold. So by getting the break-even point, they could face a profit because if example we have a break-even point of 10, then the company must produce a products of more than 10 so that they would be able to actually get a profit or gain from their operations. And it is also the standard that if they produce or sold less than 10, for example, 9 units of product, they would actually gonna face a loss. So that's the importance of break-even point, okay? So to further explain this and teach you this, let's have this example problem that I made. So a company offers their goods at a price of 15 pesos per unit. The fixed cost is 60 pesos, while the variable cost is 6 pesos per unit. When it is discovered that sales have begun to diminish, the selling price is reduced by 10%. Variable cost and fixed cost do not change. Find first we're going to find the new selling price. Second, we're going to find the break-even point. And third, we're going to find the profit at sales of 100 units. First, we're going to find the new selling price. So it is given in the problem that the original selling price is 15 pesos. And then the new selling price, as stated in the problem, has been reduced or decreased by 10%. So what does it mean? It means that the new selling price of 15 pesos now becomes 90% of the original price. So in order for us to get the original selling price, we're just going to multiply the 15 pesos to 90% because the new selling price is just 90% of the original. So 15 times 0.90 or 90% is equals to 13.50. Our answer for the first problem is 13.50 pesos is the new selling price. Okay, so that's the new selling price. 15 pesos reduced by or decreased by 10% is now 13.50. Next, we have here the break-even point. So in order for us to solve that, first we're going to list the given in the problems. So we have the fixed cost of 60 pesos. We have the price of the 13.50 pesos. This is what we solved earlier. And then we also have the variable cost of 6 pesos per unit. Okay, so the formula for the break-even point is this: fixed cost divided by the price minus variable cost per unit. So we're just going to substitute the formula with these values. The fixed cost is 60 pesos. The price is 13.50 and the variable cost is 6. So the next step that we're going to do is just subtract these values that is inside the parentheses. So we have 13.50 minus 6, we have 7.5, and then just bring down this one. So we have here 60 divided by 7.5 is actually 8. So the answer for the break-even point is 8. 8 units of products are needed to be sold to break even. So it is required that the company must produce 8 units so that they would face no gain and they would also face no loss. So it is the very optimal solution that they could have, the 8 units. So producing more than 8 units, like 9 or higher, would actually gonna get them a profit. Then the next problem is the profit at sales of 100 units. So here we're going to go to different steps. So profit, here we have the equation of profit is equals to total revenue and total cost. So first we're going to get the total revenue and then we're going to get the total cost. The total revenue has this formula: units sold times price per unit. So it is said that hypothetically we have sold 100 units. So units sold is 100 units. And what is our price per unit? So as we computed, it would be 13.50. And then we have a total revenue. We're just going to multiply this to 100 units times 13.50 is actually 1,350 pesos. So this is the revenue, or this is the amount of money that we're going to get if we're going to sell 100 units of our product. The next thing that we're going to get is actually the total cost. What is the total cost? Total cost is equals to variable cost times total units plus fixed cost. Okay, so we have here the fixed cost. We're just going to copy this from the problem, 60. And how do we get the variable cost? The variable cost is actually 6 pesos. And the units that produced is 100 units. So to get the total variable cost, we have 6 variable cost times 100 units produced is equals to 600. So to get the total cost, we're just going to add the total variable cost and the fixed cost. So that would be 600 plus 60. 600 plus 60 is 660. So our total cost now is 660 pesos. Okay. So first we have here first requirement, then we have this one. Okay. Everything is clear, as I suppose. And then what is the total profit? So total revenue of 1,350 pesos minus total cost of 660 pesos would give us a profit of 690. So 1,350 is the revenue. Total cost is 160. Just going to subtract this two. And then we will derive at this value. 690 pesos is the profit that we're going to get if we are able to sell 100 units of products. Okay? So, sorry for that. 690 is the profit. So that's it for the break-even point problem, I guess. And I hope that you have learned that how to compute that for me. I hope that I have clear instructions. Now we're going to the linear programming problems. So linear programming is a Linear programming is a method that achieve to get the best outcome in a mathematical problem. Usually, if the mathematical problem is represented by a linear equation and it is subject by a constraint. So linear programming has actually many functions in mathematics world, in the industry world. But one of those function is actually in the economics part. So in the maximization of profit. So it is applicable in the maximization of profit if a company has involved two two products and they also have these constraints in them. So If a company has two products and have constraints, then we could use this linear programming. So for a clearer view, here's an example. So if a company produces product A and product B and they have limited resources, we could use this linear programming so that the company will know how much or how many of the product A and how many of the product B must they produce in order for them to maximize the resources that they have and in order for them to get the maximum profit available with all the resources that they have. Okay, so for a more specific example, I'm going to demonstrate to you a problem. So here's the problem that I made. So Kilua company makes two types of printer, HP printer and Canon printer. Each HP printer is made of 4 kilograms of plastics and requires 12 hours of working hours, whereas the Canon printer requires 6 kilograms of plastics and 8 hours of labor. If Kilua company has 48 kilograms of plastics and 96 working hours available, and if it makes a profit of 20,000 pesos for every HP printer and 24,000 pesos for every Canon printer, how many of each must Kilua company make in order to maximize the profit? So here's the problem that I made. So just follow me for the next step so that you will also learn how to solve using the linear equation or linear programming rather. The first thing that I actually do is to make this table. So what's the purpose of this table? This table help us to analyze the problem easier. So we're just going to get the values that is in the problem. We have here first the HP printer. It is stated in the problem that the HP printer requires 4 kilograms of plastics. It requires 12 hours of labor and it generates a profit of 20,000 pesos for each unit. Moreover, it is stated in the problem that the Canon printer requires 6 kilograms of plastics and requires 8 hours of labor and it generates a profit of 24,000 pesos. Okay, so we just simplify the problem by putting it in this table. Next, step 1, okay, is define the decision variable. So what actually is the decision variable? So we're going to define what are the variables that we have in the problem. So in the problem that we have, it is how many HP and Canon printers are needed to produce. So these two are the decision variables, the HP printer and the Canon printer. Okay. So in order for us to use those variables, we're going to represent it using this two. So we're going to have X represent the HP printer. We're going to have Y represent the Canon printer. Remember these two. We're going to utilize this representation in our next steps. X for HP printer, Y for Canon printer. Okay, those are the two decision variables. Next step, define the objective function. So the objective function is actually we're going to find out what is actually our objective in this program. So as stated in the problem, our objective is actually to maximize the profit. And in order for us to do that, we have here the equation for maximizing the profit. Maximize profit P is equals to X times 20,000 plus Y times 24,000. So you're probably thinking, where do I get this value? So let me explain it to you. So P just simply represents the profit. P is in for profit, okay? And then X, as I stated earlier, X is for HP printer and Y is for Canon printer. And these values. So 20,000 is the profit that we're going to get for selling the HP printer, and 24,000 is the profit that we're going to get for selling the Y printer. So by adding these two variables, by adding the profit for HP printer, by adding the profit for Canon printer, by adding these two, what do we get? Of course, if we add the profit for these two products that the Hilwa company have, then it will result to the maximum profit. That's why our equation would be maximum profit of P is equals to X times 20,000 plus Y times 24,000. Okay, all clear? That is our equation for maximizing the profit, getting the profit of HP, then adding it to the profit of Canon printer. Next step that we have here is define the constraints. So basically, constraints are the limits that we have in the problem. So what are the limits that we have? It is actually the resources of plastics and labor available for use. So as stated in the problem, we only have limited labor and plastics. So here's the equation that we're going to use. Plastics is equals to 4x plus 6y is less than or equal to 48, and labor we have 12x plus 8y is equals or less than to 96. So how do we get these equations? So as stated in the problem, we only have 48 kilograms of plastics. That's why we have 48 here. So why is it 48, and how do we do this? It is stated in the problem that we are requiring 4 kilograms for the HP printer. So X represents HP printer and 4 represents the kilogram of plastics that the HP printer needs. And then we're going to add that one to the plastics needed by the Canon printer. So again, Y represents the Canon printer and 6 represents the amount of plastic needed to produce a Canon printer. So adding these two, adding the plastics needed for the HP printer by the plastics needed by the Canon printer, the amount of that two should not be more than 48 kilograms of plastics. Why? Simply because the company only has 48 kilograms, and producing printers that requires more than 48 kilograms is not possible for them because they don't have that enough amount of plastics. So that's why it's only less than or equal. Why is it equal? Because they could actually use all of those 48 kilograms of plastics. So using the plastic for the HP printer and the Canon printer could be equals to 48 kilograms of plastics or less than it. Okay, so that's why we have the equation of plastics here. Next, we have the equation of labor. This 96 that we have, it is the hours of labors that is available for the company. And then X again represents HP printer. So the HP printer requires 12 hours of labor. So we have here 12X. And then the Y represents the Canon printer. And every Canon printer requires 8 hours of labor. So by adding these two, by adding the labor needed for the HP by the labor needed by the Canon printer, the amount should not be more than 96. Again, why? Because they only have 96 hours of labor, and producing printers that requires more than 96 hours of labor is not possible for them because they don't have enough time now. So they could also be equal to 96 because they could actually use all of those 96 hours that they have. That's why the labor for the HP printer and the Canon printer, when summed up, should be less than or equal to 96 hours. Okay, so that's the equation for the labor. And then we have here X and Y should not be equals to 0. Of course, in this problem, we are finding out the maximum profit, and then we can't get the maximum profit if we're going to produce zero products. So X and Y should not be zero. Producing a zero product means no profit, and that's not a maximum profit. So the next step that we're going to have is this. So we will finalize the equation. So our final equation would be maximize profit P is equals to X times 20,000 plus Y times 24,000, and it is sentence 2. Plastics is equals to 4X plus 6Y is less than or equals to 48, and then labor is equals to 12X plus 8Y is less than or equal to 96, and Y and X cannot be 0 or equal to 0. Okay. So here's the final equation that we're going to use in the problem. Okay, this one, this is the sentence. I have explained it to you earlier na naman. Okay, next. The next step is getting possible points for the graph to be made, substituting the constraint to the value of 0. So the next step that we are going to do in order for us to find the maximum profit is actually to get a graph. And in order for us to get a graph, we first need to get the coordinates for the graph. So how do we do that? We're just going to substitute the constraints that we have by the value of 0. Okay, so first step that we're going to make is this one. We have the equation for plastics. Plastics is equals to 4x plus 6y is less than or equals to 48. So the first thing that we're going to do is to substitute the x by 0. So this would be 0. So basically 4 times 0 would actually be 0. So these two would be the remaining. And then in order for us to get the value of y, we're just going to divide it by the value of 6. So 6y divided by 6 is y. And then 48 divided by 6 is 8. So in here, we have the value of y is equals to 8. Okay. Then we're going to just repeat the procedure. In this time, we're going to put the value of y into 0. So that's basically 6 times 0 is 0. So we have this two, 4x and then 48. So in order for us to get the value of x, we're just going to divide the 4x is less than to or equal to 48 by 4. Okay. I'm sorry for the lousy writing. So 4x divided by 4 is x. And then 48 divided by 4 is actually 12. Okay. So from that, we could see that the first coordinates that we have is x is equals to 12, this one, and y is equals to 8, and this one. And then we're also going to do the same in the equation of the labor for us to get the second coordinates. So the equation for labor is 12x plus 8y is less than or equals to 96. We're going to replace the value of x by 0. So this would be 0 because 12 times 0 is 0. So we only have this two. And in order for us to get the value of y, we're just going to divide it by 8. Okay. So 8y divided by 8 is actually y. And the 96 divided by 8 is actually 12. So first we have the value of y is equals to 12. Then this time we're going to put y, this one. We're going to make it 0. So 8 times 0 is 0. So the remaining equation that we have is 12x is less than or equal to 96. To get the value of x, we're just going to divide it by 12. Okay. So 12x divided by 12 is x. And then 96 divided by 12 is 8. And from that, we now have our second coordinates. X is equals to 8 and y is equals to 12. Okay, so this one's the second coordinate. This one's the first. This one's the second. And then how are we going to use it? Okay, just follow my step. So from getting the coordinates, we now make a graph. Okay, this is the graph that I made. So the first coordinate is 12 by 8. So after plotting these numbers, we could graph the coordinates that we have. Here's the 12. 12 is x and 8 is y. 12 and then 8. That's the first coordinates. Second coordinate, x is 8 and then y is 12. Okay, this line. Okay, as you can see, this line and then this line. So we could actually use this graph in order for us to get the optimal solution to maximize the profit. So their intersection would mean this point we're gonna give us the maximum profit because it's going to use the maximum resources that we have. So since we cannot exactly know the value of this 4.8, 4.8 is actually solved by mind, and I will explain to you later how to get that value. So here's the point. If we're going to use the graph, it's easy if just its exact number, but since it's not exactly pointed at the coordinates of 5, 5, we're still going to get the exact value of it in the next steps that I'm going to teach you. Okay. So just take a good look at this graph, just plotting the coordinates, and then getting their intersection would probably, but not all the time, gonna lead us to the maximum profit. Okay, so next step, in order for us to get this 4.8, 4.8, substitution of a variable to attain common variable in equation. So what does it mean? How do we do that? So we have the formula for the labor and the plastics. And I will transform the equation of the plastics to be able to use it in the equation of the labor. So I will first get the equation to get the value of x. So as I have said, we have the equations for the two constraints, the plastics and the labor. So first, we're going to utilize the equation of plastics. So the equation of that is 4x plus 6y is less than or equals to 48. Just copy that one. And then we're going to make it so that the x and y would have the same value. How do we do that? So we're just going to transpose this 6y into this side. That's why in this equation we have 4x is equals to 48, just copy. And then 6y transpose, that's why it now has a negative sign, minus 6y. 4x is equals to 48 minus 6y. And how do we get the value of x? Just going to divide it by 4. So 4x divided by 4 is x. 48 divided by 4 is 12. 6 divided by 4 is 1.5y. Now we have this value of x in respect to y. Now, since we have that, we're going to use it in the equation of labor. Okay, just remember this. X is equals to 12 minus 1.5y. Okay. Next step. So we're going to utilize or substitute the new equation for the equation of labor. Again, what is our equation for the labor? For the labor, we have 12x plus 8y is less than or equals to 96. And we're going to use the equation that we solved earlier for this one. So just copy this from that. And then we can see here the x, I substituted it already. So we have 12 x substitute by the equation earlier, 12 minus 1.5y, and then just copy 8y here, copy 96 here. So we now have this equation. So first thing that we're going to do is to multiply the equations inside the parentheses by the value besides it. So 12 times 12 is 144. 12 times 1.5y is minus 18y because it's negative. That's why it's also negative. And then we're just going to bring down the y, 8y, and then also the 96. The next thing that we're going to do is to mix the common terms. So we're going to mix this one, negative 18y plus 8y. The answer would be negative 10y. And then 96, just copy it. And then the 144, we're going to transpose it to this side. That's why 144 now become negative. And then from that, we're going to simplify the equation now. So 96 minus 144 is actually negative 48. But what I did is just multiply both sides by negative 1. Since this is negative and this one is also negative, negative 48, it will equals to positive 10y 2 is equals to positive 48. Okay, so it's the simple mathematical concept. So in order for us to actually get the value of y, we're just going to divide this equation by 10. So 10y divided by 10 is just y, and 48 divided by 10 is 4.8. Now, after that, we now have the value of y. And what we are missing now is the value of x. So let's now solve it. Remember this one, the value of y is 4.8. Now, we're going to solve for the x. So just use another equation of constraints. So 4x plus 6y is equals to 48. And as we have solved earlier the y, we're going to substitute this y by its real value, which is 4.8. So just substitute it. Copy down for x. 6 times 4.8, which is the value of y, is 28.8. Then bring down the 48. And then what we're going to do is to transpose this one into this side. So we have 28.8. So 4x bring down, and then 48 minus 28.8 would be 19.2. And to simplify the equation, in order for us to get the value of x, we're just going to divide it by 4. Okay. So 4x divided by 4 is x, and 19.2 divided by 4 is 4.8. So as we can see here, the value of x also have 4.8. So the optimal solution for x and y is 4.8 units. HP printer is 4.8 units. Canon printer is also 4.8 units. So it's the optimal solution that the company have in order to maximize profit. Okay, 4.8 units, 4.8 units. It is seen in the computations that we have. Next. Okay, so in order for us to actually get what is the maximum profit, so we're just going to substitute the optimal numbers that we get. So the equation for maximizing profit is maximized profit P is equals to X times 20,000 plus Y 24,000. Again, X is HP, Y is Canon, and then 20,000 is the profit for each HP printer, and 24,000 is the profit for each Canon printer. So since we have the optimal solution of 4.8 for the HP, 4.8 for the Canon, then we're going to multiply it to the profits that they have respectively. So we have 4.8 HP printers multiplied by 20,000 of profit. It would now derive at 6,000 pesos. And then 4.8 multiplied by the profit of Canon, 4.8 times 24,000 would get us 115,200. So this one is the profit for HP. This one is the profit for Canon. And by adding these two, we would now get the maximum profit of 211,200 pesos. Profit for HP of 96,000. Profit for Canon of 115,200. Add up. We now have the maximum profit of 211,200 pesos. Okay. And to finalize our answer, yan, this one. If Kilua Company produces 4.8 printers and 4 HP printers and 4.8 Canon printers, it will receive a profit of 211,200 pesos, the maximum profit possible given the resource constraints. So if the Kilua Company have 4.8 HP and 4.8 Canon, we will get this profit, 211,200 pesos. And it is the maximum profit that we could have. Okay, so that's the answer for the problems that we are solving. But that's not the end. We still have the recommendations, okay? So bear up with me. What's my recommendation for this? So for recommendation, taking into account that it could be used for a real-life problem, the computation results would not be feasible because Kilua Company have to produce a whole unit, not 0.8 complete. So what does it mean? So since we get the optimal solution that the Kilua Company must produce 4.8 of each printers, but if we think it in the real life perspective, this zero point 0.8 is not feasible. It is not possible for the company to sell a 80% complete printer. So what we're going to do is that we're going to look to the closest to both the numbers. So I have tried picking up points which are near that one. So I tried using 4 HP printers and 5 Canon printers, but the resources that are needed to produce that amount of printers are not enough for it, okay? And then, moreover, I tried 5 HP printers and then 4 Canon printers. And luckily, the resources are enough to produce it. And then we will get the profit that we could derive from producing that unit of products, and that would be 196,000. That is the profit for 5 HP and 4 Canon. It is substantially lower than the maximum profit of 211,200 pesos, but it is higher compared to producing 8 Canon printers or 8 HP printers. So producing 8 HP printers would just get us 160,000 pesos of profit. So this one is higher. And then producing 8 Canon printers would get us 192,000 pesos. So this is still higher. So overall, my recommendation that since it is not possible to produce 4.8 or 0.8 80% complete printer, then the Kilua Company must resort to producing 4 HP printers plus 5 Canon printers because it is more realistic. So Kilua Company must produce this. So remember in our minds that by using this linear programming, there are cases where we can't actually get the exact numbers that we have, just like in the problem that I have given. So the result is not in whole number and it would actually gonna cost us a problem. So we must also look to the other points in the graph. We're going to compute for the profits by using these different points, and from that we could actually now derive at which point is possible in real life and which point would actually get us a high profit, although not always the maximum profit. So that's the conclusion. But if we're going to just discuss it by using the linear programming, then this one is applicable. 4.8 HP and 4.8 Canon. But in real life context, we must resort to 4 HP and 5 Canon printers it is available for the resources, and it still give us a high profit. So that's all for today's video. I hope I have explained to you extensively how is this linear programming maximization of profit is working. And before I end this presentation, let me give you a quotation by Paul Hawker. Good management is the art of making problems so interesting and their solutions so constructive that everyone wants to get to work and deal with them. By Paul Hawker. And if ever you have any questions, don't hesitate to contact me at my email amonjericho0290 at gmail.com, and my phone number is 0963-295-1995. Again, thank you for listening, and I hope you have learned a lot from me regarding the break-even point and the linear programming maximization of profit. The Lord be with you, and thank you for listening.